Welcome to Anything Maths. This video deals with motion under gravity. Like the video and join the Anything Maths family by subscribing. In most cases, gravity is represented by the letter G, the small case g, and the value of G is 9.8 meters per second. So we have G 9.8 meters per second squared. That's acceleration. There are few assumptions that we want to make. That we're not going to consider air resistance, frictions, or anything that will impact on that vertical motion. And as a result, then G is going to be 9.8 always in our calculation, unless we are told or informed otherwise. In some questions, they will say let G to be 10 meters per second squared, just for easier calculations. So we established that G is going to be constant. And if it's going to be constant, then it can work well with the 5 equations that we derive under the topic motion under constant acceleration. Let's remind ourselves of those 5 equations. The first one is the final velocity is given by the initial velocity plus acceleration times time. The second one is the displacement is half of the initial velocity plus the final velocity times time. The third also deals with the displacement, knowing the initial velocity plus half at squared. The fourth also the displacement, but this time the final velocity minus half at squared. And the fifth deals with the final velocity squared should be equal to the initial velocity squared plus 2as. So under this motion, under gravity, there are few adjustments we can make. It's quite clear that G is constant. So the first equation becomes V should be equal to U plus GT. The second equation will not change because there's no A in it. The third equation will also be altered. We have that plus half GT squared. The fourth will also change, but that's also got acceleration GT squared, and this will become V squared minus U squared plus 2gx. I just want to remind you, when it comes to motion under gravity, that's the vertical, there's an idea of what we call a sign convention. Okay, sign convention. We know that always acceleration due to gravity is coming down all the time. Doesn't change the direction. But in calculations, we can adopt our own sign convention, and that can affect the sign of G. So for example, if I'm solving a question, I said all motion upwards should be positive, it means anything that is coming down will be negative. And as a result, my acceleration will be negative. So the sign of 𝐺 here is going to change, okay, based on your calculations. Okay, if I said anything that goes up is negative, then it means anything that comes down will be positive, and therefore 𝐺 will be positive. So these sign conventions are really, really important. It doesn't really change your answers. What it does, it changes the sign. But the sign will have a meaning because of your sign convention. Let's look at some typical example that will help you to understand this sign convention really well. This interesting diagram will help us to understand how to solve a typical question. So imagine that at point A, an object, this is A, and upwards with initial velocity u, and it gets to a point O and also return to point B. Okay, and we can see that that object is now above the ground h0 or HO. The question is, find the time of flight. What do I mean? The total time it takes from when it was projected till it lands at the point B. That is what the time of flight is. Okay, or the total time. How are we going to find that total time? From that equations that we derive, because we know the initial velocity and we are looking at the movement in a vertical way, not the path of the object. That's why we are saying a vertical motion. So it goes from A and get to point O and come back to A. The displacement is 0, and it goes further h0, and so the displacement will be negative h0. Okay, so that's the displacement. So the equation that we want to use is x is ut plus half at squared. But we need to do something in our calculation. We want to tell the examiner that we are saying going up is positive, and this will mean that 𝐺 is what? Negative. Okay, 𝐺 will be negative. And from the question, we know that x is now negative h0. What we have to do is to make substitution into equation 1. And if we do, we're going to have negative h0 should be equal to ut minus half gt squared. What do you do next? It's quite clear that this is a quadratic in t, where it can be 2gt squared minus
ut minus h0 should be equal to 0. Multiply through by 2, we're going to get gt squared minus 2ut minus 2h0 should be equal to 0. Now, using any appropriate method for solving quadratic equation, you should be able to find two values of t, and based on those values, you can work out which one is the time of flight or the total time that the particle took from point A to point B. So these are some of the ways we can apply the idea of motion under constant acceleration to vertical motion under gravity. This is just an introduction. My next video is going to deal with questions, examination type of question. And so make sure you like the video and subscribe as well, so that when I upload a new video on concerning those questions, you will be able to watch as well and get a better understanding of this particular topic.